Okay, so this week we're going to be covering finite element analysis. For your guys' vehicles, if you guys still don't have your skeletons completely up and ready by now, you definitely should talk to the TAs, make sure that's up and running. Definitely get a lot of your modeling done, because from here on out we're going to be doing a lot of analysis. And so in order to do the analyses, you have to have parts to do analysis on. So we'll be doing finite element today. Next week we'll be doing assembly finite element. And so you should have a small subassembly finished in your vehicle that you can do the subassembly analysis on for next week. Make sure you guys are keeping up on topology optimization. Hopefully those are getting close to being finished for you guys, so that way you're not going to get bogged down at the end of the semester.
It's just one part per person.
One part per person, yep. And then we'll be doing some CFD and some motion simulation as well. So you'll definitely want to have parts of your vehicle subassemblies finished in the next coming weeks here as we get ramped up to do all of those final analyses. So today we're going to go through finite element for a single part inside of Catia. There are other packages available out there like Astran, ANSYS. This one is just built into Catia. And so you guys will be able to apply loads. You'll be able to constrain the models, mesh them, figure out ways to basically do a complete analysis on them. And so I'll kind of walk you guys through that and help you guys out with that. All right. So if you guys want to pull up Catia, we can go ahead and get started here. I've uploaded a part onto Team Center Community under Lab 9. It's called rod.cat part, and so the part is slightly different than the one that's on the picture on the actual homework assignment. But for this assignment, let me pull it up real quick here. Make sure we're clear on what's expected. Yeah, I can do. I think I can unplug that. Okay. There we go. Okay, so for the homework, we'll be doing FEA, breaking things down and getting basically a solved model. We'll generate a report. And then you're going to use the same techniques that we'll do in this tutorial for an analysis of your lower control arm inside of your subassemblies. And then you'll create a PDF of that report. You'll add images to the report. So for in-class submissions, there should be 2 PDFs. That's going to be an individual submission. And then for the homework exercise, you're going to apply the FEA techniques that we'll learn today to the components of your vehicle that incur structural loads. So you can start with the most critically loaded components, making sure they're sized correctly and have appropriate transition shapes and blends. And then after applying FEA, you'll generate a simulation report with an image of that showing the deflection and the stress. So I'll show you guys how to generate the report. But like I said, you'll need parts inside your skeleton model to actually do a lot of these analyses. So make sure that you guys are staying up on top of your modeling.
Now, we can do an analysis on a part that may have been done in topology just because of the force inside.
Yeah, exactly. Yeah, it's just fine. The parts themselves, whichever ones you guys do, doesn't really matter to me. Some of them you might want to consider would be like the subassembly for like the tire, the lower control arm, the suspension shock tower, because those will hit loads. If you like hit like a pothole, or if you're driving, you need to turn or whatever, and you slam into the wall. You could also do one for the bumpers. It's like the bumper's going to collide into a wall, so maybe you want to do an analysis of, what happens to the bumper when you smash it from like coming at an angle or head on or something like that. So those would be some typical parts. But yeah, chassis, like what happens if you drop your race car, So those are some things that you'll probably want to consider. Okay, so in NX, they've put together a tutorial using screenshots from the help file. So today we're actually just going to go through the help file. There's about 5 different sections on there on how to do it. Plus this will give you guys basically a resource to go back and repeat the analysis for the other parts that you'll do. So I've got a part already uploaded onto Team Center Community, but essentially it is, let's see if I can find it here. It's this part right here, rod.cat part. So this is a connecting rod, and so we're going to go through the tutorial inside of Catia to kind of get an analysis, figure out how to mesh this thing and things like that. So if you go up to help, you can go to the Catia V5 help, and it should bring up Windows Explorer. And if you click on home, it'll take you to the Catia documentation homepage. And inside of the Catia documentation homepage, there is an analysis option. And then here, the very first one is called Generative Structural Analysis. That's the mode that we'll be using for the FEA for both individual and assembly finite element analysis. So if you click on that, it'll bring up a bunch of different types of tutorials, and we're just going to step through the first tutorial, and I think there's like 5 or 6 parts to it. So went to help, and then I clicked on the home documentation homepage, and then to the side there was an analysis tab, and then I clicked on generative structural analysis. Okay, so we're going to just go to the getting started. The first thing says entering the generative structure analysis workbench. This one should be pretty easy. Before you hop in there, you need to make sure that you've applied a material to your part. So if you go into Catia, let's see here. To apply material, so I'm still in part modeling. To apply material, there's a button that does that for you. It's right here. It's kind of a hollow box with a little blue sphere that's being dropped onto it. So if you click on that, it'll bring up a list of all the materials that are inside of Catia. And so you can go ahead and pick one. So like we can go to metal, and we can apply aluminum. So you just click on it, drag it down to your part, and let go. And now your part should have aluminum. The way you can check is if you open your part tree, there should be a material in there. Yep. The other way, yeah, there's a little drop down here that says, let's see here, shading with material. So if you turn on that visualization filter, it'll show what type of material's on there. So got something in aluminum there. Okay. So now that we've got our part inside of Catia and we've applied a material to it, we're going to go up to Start. Go down to Analysis and Simulation, and then we're going to want to go to Generative Structural Analysis. Okay? So if I go into General Structural Analysis, it will create an analysis part for me that is linked to this part model. So anything that I change inside of the part model should reflect inside my analysis model. Okay? So we want to do a static analysis. There's a variety of other analyses that are available. One of them, frequency analysis, it gives you the natural frequency as you bend the part. We're actually not going to use those for this course. But if you do want to learn what they're used for as well as how to use them, you can continue on with the tutorials past the tutorial that we'll cover today. So that's just kind of for the interested student. So we'll go into static analysis, and you'll notice that if I expand the part tree, this already has a mesh applied to it. So if we come down here, it'll say the Catia, the cat analysis document now opens. It has a name, and then there's a link existing between the cat part and cat analysis document. If you double click on the green symbol, it allows you to display mesh specifications or set meshing parameters. So if you come back in here into Catia, there's this green kind of unusual item here. If you double click on that, you can change the parameters of your mesh. So you can change the size of the mesh, the sag. You can, if I remember right, that's how many, actually, let me see here. I don't want to lead you astray here. Let's see. I don't remember exactly what it is. I think it's just the tolerance on it, if I remember right, but I'm not sure. So the size of the mesh is what you can control the easiest. So like you can change it to like 12. You can insert a formula and change it to be parametric if you'd like to. So there's a whole variety of things you can do there. And then there's also different types of mesh that you can add. So if we hit OK.
So parabolic is the second one? Is that how you change the first one and second one?
Yep. And then if you pull out there's a whole bunch of menus here. So I'm going to pull some of these out. We're probably going to use a good chunk of these. Almost done. There we go. Okay. So I pulled all those out. All right, so if we come back here, it says, so we can change the mesh. As you can see here, your part tree will have a set of loads, restraints, static case solution, and sensors. So we're going to populate each one of those items in order to get our finite element analysis results. So the first thing we need to do is we need to create some restraints. Basically, we need to constrain our model. So if you go to the next item here underneath getting started, it'll say creating a surface slider restraint. So this task will show you how to restrain several faces of your part in such a way that you can only slide them along their tangent planes. So this is one of the many types of constraints that you can put on your model. We'll click on the surface slider in the restraints toolbar, and then we can select in sequence the four faces as indicated. So this one, the front side of this, and then the other side, and then this little portion right here. So come into our model, bring it down, and then we've got our slider constraint, which is right here. If you want to do like a cantilever, there's a clamp. So you could literally constrain it so it can't move in 3 directions and can't rotate in 3 directions. So that's one way you can do that. This surface slider will allow it to slide. So if you click on that, we can select this face, this face, this face, and this face. So the slider will allow translation. So when you're doing finite element analysis, if you want to apply a deformation load onto something, you can constrain the model so that it'll allow it to bend in certain ways. So like, for example, a cantilever beam, if you put a clamp on the end, then if you apply a force onto it, it'll allow one end to stay where it is, and the other end will kind of bend down. But if you apply a slider, the whole thing could slide up and down. So it's not fully constrained on the one end.